It is a handheld system for mobile tracking of objects, so you have the possibility to obtain all informations without technical efforts. Multimodal object characterization. If you have an object, it can be characterized by different informations. The 3D shape and motion. We have temperature information, we have geometric information, we have color information. Now I will make a last big step. If you have transparent objects, the situation will be much more difficult, and for this we have developed application and technical solutions. In the next minutes I will give you some information about multimodal 3D measurements, and I will speak about different systems we developed here in our team. Let us take a look in the time scale for the development. First, we will start with the standard 3D imaging. That means X, Y, Z informations about the object. Maybe some color informations also. You can look around the objects. If we want to extend this and we want to go further in the multimodal sense, we can include a new dimension, that means the time. We have then no static informations, we have a dynamic situations of the object, and we want to scan the object in movement or in fast movements. And the next clear step is then, if you extend it to the wavelengths, then you have much more information about the situation. You have the geometry information, the temporal information, and you have the spectral response, the spectral behavior of the object in the time scale. So I will start with the explaining of some different setups, and the first I want to show is the system Go Scout 3D. It is a handheld system for mobile tracking of objects. We have here a picture of the setup, and the setup consists of different technical parts. We have in the center a high-resolution camera for scanning the object, illumination systems for giving the light, and a touchscreen systems for getting the control about the system. You have an inertial EMU unit, then you can get the position and the movement of the sensor head. Let us take a look in the detail. What does it mean to scan an object with such a system? You move the system around the object by slowly moving on different positions. You get a stack of images, and during this process you get the position and the orientation of the sensor head. It is a very useful way to get a 3D complete description of the object you are measuring. You have the pictures of the object, the intrinsic sensor parameters and the extrinsic sensor parameters from the movement of the sensor, and then you obtain a 3D point cloud colored, and in addition you have high resolution 2D pictures. That means you have a combined information, the object for navigation and viewing, and high resolved detailed pictures. Here we see it again. On the left side you can see my colleague. He scans the object. It takes only a few minutes to go completely around the object, and then you have the possibility to make a detailed analysis of all informations. Now I can show another example where you can use this digital twin. If you have a car engine, here you see a lot of details and the old configuration, and you get all details of the system. You can make a complete data reconstruction, and you have the possibility to make a 3D digital twin of such an unknown object. And here you can see it in the outside area, stones and historical objects. You can see in the movement the high resolved surface, you can see the color information, and you can see it is usable for indoor and outdoor application. You can scan larger areas of objects in an outdoor environment without any preparation of the scene. Another application can be commercial systems. You want to scan objects in a shop, you want to make a reverse engineering, you want to scan architecture objects or video animations. You can use it in a virtual reality glasses. So you have the possibility to obtain all informations without technical efforts. Now I want to switch to systems which using near-infrared lights. What is the advantage of this? If you want to scan persons, they should not be irritated from the light. And that means the person should not see the light. The scan should be completely contactless, and without any irritation of the persons. And this scan should be very quick. That means we must have a live scan, we must have a live feedback of the situation, and we have continuously information about the movement and scanning persons in movement and color information as too. Here are some possible applications, what we can do with this. You can scan patients. If you have a problem in your skin, in your face, you can scan it without any irritations. You have the first surface and you can make epithesis, or you can make respiratory masks for patients, and you have the 3D informations about these objects without any contact and without any irritation. Another interesting application is in medical applications too. If you have patients in an X-ray radiation therapy, then the patients must be on a very specific positions. And if the patient is moving, then you must track this moving, and you must have the possibility to check the system. And if the patient is moved, then the position must be corrected or the radiation must be stopped. Here you can see 3 sensor heads around the patient. Why 3 sensors? The therapy system moves around the patients. We will see it in the next video. And it is designed in the way that you can scan it in a real-time scan in some milliseconds latency, and you can get the patient position completely around during the whole treatment. The system moves around the patient, the sensor heads are out of the view on the top of the system, and then the movement of patient can be very clear scanned and monitored. That is very helpful that you can use it in radiation therapy and reduce the problems for the patient. Here another application, it can be used for contactless measurement of tidal volume. If the patient is scanned without any contact, you can measure the chest and see the movement and the volume of the single tidal volumes. In the next pictures we see this. We have different scans through the body. That is a 3D information, and that is an animation of the person. And here you can see it is a very high resolved information. You have here a scale of some millimeters, and you see the movement of the body. Another interesting thing is if you have some patients with problems in movement, they cannot simply move, they have some motivation problems, and for this it is very helpful if they are motivated to move and to be active. And that is not so simple. And one interesting way in this is the so-called music therapy. That means you make a combination of movements of the person and sounds, music, so they can change and interact with the music and get an active person because they are in direct interaction. Here we can see it in an animation. My colleague here is moving and you can hear it. It is like he is playing a piano. You can play and he can move his body and he get a direct feedback of this movement. And for this it is a very good acoustic feedback, the combination of music, acoustic feedback and motion. The next possible applications, persons who cannot move. You can see here how he is moved, how the sound is in interactions, and how the person can get directly feedback and happiness. So we have seen some setups, some systems, and we can take back a look on the whole overview. What does it mean? Multimodal object characterization. If you have an object, it can be characterized by different informations. The first information is of course the 3D shape and motion. We have temperature information, we have geometric information, we have color information. And this all means if we are only look on one channel of this, we don't get all information about the situation. If we are able to scan more of this, we are able to get a complete and more overview information about the situation. What are the technical basics of this? Here again a picture, we have a movement situation, we have different channels, RGB and real color, we have different spectral informations, we have a thermographic camera, and all this information should be combined in one complete scan. And if we are taking a look in the technical background, that's the so-called 5D imaging. That means normally we have a 3D sensor system which can give the information of the object. The cameras take the pictures and we have the simple standard informations. And if we want to extend this, then it is very useful to include more informations, multimodal imaging informations, maybe in RGB cameras, multispectral cameras, infrared systems, polarization cameras, and so on. And this gives us the information about the object in totally. Why is this interesting and important? Here I have a picture of different fields where simple daily questions can be asked. Is this fruit ripe? Interactions between persons. What is the interaction? What is the behavior of one person? Technical systems. Is there a defect in the system? Is necessary to repair? Plastic materials. Recycling. What kind of plastic is this? And what kind of recycling processes will be done? And some other technical things. What is the technical situation in the environment? And what is the information I can use it for following actions? One technical systems which can be answered on this here is shown in the picture. Multi-camera solution. We have different cameras and illumination setups to give the information in the space. And if you have such a setup, you can get multimodal informations. You can get the 3D dimensions. That means the mesh, the coordinates, the color indicates the deeps. You can the picture in the real color. You can use another spectral range and you scan the temperature. That means you get much more information as only taking the normal picture with the camera. And one possible question for this is, for example, you can directly measure the heart rate, oxygen saturation, aeration rate, and the body temperature. Here you can see it in a picture. You see the person, it is moving, the mask is moving, you can see the temperature of the hands, and it can be set up as a complete all-in-one systems for scanning patients in a medical situation. To imagine what is the advantages of this, if you want to scan babies in a neonatal care situation, then it is very helpful if you are working contactless and you can scan this situation without any direct contact to the body and the skin. Another field where it's very interesting to have such information is the field of security applications. Here you have some optical sensor gates where a security access or border control access is possible. For this you must scan the persons, you must scan the face, and you must have multi-informations. If you have only a picture, it is simple to fake. And if you have multi-spectral informations, it is not simple. Here is a picture. If you have a mask on it or you have spectral informations, you can separate between real persons and fakes and simulation. Another application is if you want to scan movements of person, it is helpful to scan the movements in the space, and you have the separation of the hand of the object and the movement, and so you can separate the hand, the technical object, and the pose of the system. It is useful in technical applications and movement surviving in production purposes. Now I will come back to the point of agriculture. Here in the left side you can see the behavior of a plant if the water is going out, and in the multispectral range you can see over the time the water missing will change the information. And it is useful for applications of harvesting and agriculture systems. For this it is not helpful to have only a picture. You must have a multispectral picture to separate the objects, and then you can go directly to the interaction with the robot system. Another interesting application is measuring of content on a surface. Oil spots can be scanned with fluorescence imaging. That means you have an object, scan it in a normal 3D scan, and you have an illumination with UV LEDs, and you get fluorescence images of the object. That is a normal 3D scan on the right side. And if you have the fluorescence pictures, you can detect oils directly on the surface and localized on the object geometry and make then cleaning processes. Cleaning process is another topic too. If you are in a medical environment, it is helpful to have an automatic systems to be able to scan object surfaces, to scan handles, to scan areas, making automatic disinfections and you have the possibility to scan the complete environment in an automatic setup and make some disinfections processes and have 3D informations combined with object disinfections. Now I want to jump to high-speed setups. What does it mean? High-speed applications can be, for example, crash situations, airbag explosions, and something else. Here's a stationary system which can scan from the outside a crash situation with high-speed cameras, and on the right side you see a movable sensor which can be used directly in a crash interaction into the car. Here we can see such a kind of scan. We are pressuring an air brush to a pillow, and on the right side you can see the very high speed. We are in the range of some milliseconds. We can scan up to 50,000 scans per second. That means at a very high rate we can obtain all informations on very high speed events. And here we see it on a car. It crashed by the side, and on the left side you see the video of the car crashing to this wall, and on the right side you see the 3D information of the deformation of the object. That is the geometric and the time scale, and we can extend it to a next level. We can include a thermal camera so that we get the temperature information of the object too. That means we have the 3D dimension, we have the time, and we have the temperature information. Projection unit, the cameras for 3D scanning, and the thermal camera. And here we can see it in a simple demonstration. We push the hammer on a tube, a metal tube, and here you see the deformation in a time scale. The color indicates the temperature. You see on the hammer the hand temperature, and you see the deformation of the tube, and in the center here the temperature is increased because of the strong deformation. And another example, if you push a ball, then you can see the hand on the ball, and you can see the imprint on the bottom if the ball is pushed on. And the last application, I hope never will see it in practical, but it is very helpful and very useful system, the explosion of an airbag. And you can see on the right side the video of the explosion, and on the left side the 3D information, and the color indicates here the temperature of the object. That means you can see the temperature information on the surface of the object during this process. And again, it is a high-speed process. We have here only some milliseconds describing the situation. Now I will make a last big step. What does it mean? We have seen all times object with a surface which can be seen with the camera very easily. If you have transparent objects, the situation will be much more difficult because you don't get light from the surface. And for this we have developed application and technical solutions to scan transparent objects, that means difficult to scan, with the help of a special thermal 3D measurement technology. And we are able to scan then the surface without any kind of preparation and without any kind of interaction with the surface. Here some examples and some results. On the left side, the picture of a honey jar, normal sensor scan in the middle, and at the right side, the 3D scan with the thermal technology. For this, we have realized a technical system. And here again, some examples. On the left side, flacon. It is a glass object with a metallic cap. In the middle, the 3D deep map, and then the 3D model. And on the right side, again, a glass photo, and then the color shaded, completely measured around situation. That can be used in a lot of technical and other applications. You can scan glasses, directly scanned without any preparation, or aligners for dental use. And this can be done for handling applications, for robot gripping, for object detection. These solutions can scan transparent objects. We are able to scan also dynamic situations. You can see how this plastic bottle is pressed down, and we have a scan which is in dynamic scanning, and we get dynamic information about this object. If we are scanning the surface, we can't look inside. For some situations, it is helpful to have also the inner dimensions of objects. We can scan the objects and can look inside the objects with computer tomographic setups and getting detailed information about the surface and the internal structure of an object at the same time with a very high resolution in the range of some micrometers up some 10 micrometers. Here in animation we scan this lens object and you can see the structure and the internal structure about a whole range of surface. With conventional optical methods it is very hard to get the information in the same way. And some other examples, you can scan technical objects, 3D printing objects and biological objects. You can get geometrical information about this and can check if the construction is made in the right way. So that was a very short overview about different possibilities, and thank you for your attention.